Ladies and gentlemen, boys and girls, welcome to another episode on the Incredible Academics YouTube channel. Basically, today is just going to be a continuation of what we covered last time, but the context is going to be a little bit different. We are no longer going to look at quadratic functions. Linear functions. We're not going to be looking at quadratic functions. So, the day today is the 3rd of January 2024. Yes, so as you can see, we've got the standard form here. So this is as per the prescription from the CAPS document. Okay, so this is the standard form that we're going to be looking at. Forget about any other type of quadratic standard form of the quadratic function. And I've given you guys an example already. Y is equals to 4x squared, which is the quadratic function that we're going to be looking at. So let's move away from these type of functions and start using f of x notation. So f of x is equal to what? 4x squared. That looks pretty, isn't it? Therefore, find f that, right? Whether there's the brackets and the x there, or there's just f to the exponent negative 1, just know that this is what? The inverse. Don't let anyone confuse you. So, remember what I said. To find the inverse, we need to swap x and y. Okay, swap x and y, and you can see that the f of x actually represents the y. So in place of the f of x, we put the what? X, and in place of the x here, we put the y squared. All right. And now we've got a little bit of a conundrum, because we need to make y the subject of the formula. So what do we do? Okay. Unfortunately, you guys can't tell me what to do, but normally if I was in class, I was gonna let my learners tell me what to do, because I know they're super smart. Right, so there we go. And now we need to square root both sides. So the square root of so this is x squared plus minus, okay, x squared over 4 is equal to the square root of y squared. Okay, so now this becomes what? The square root of x squared is just going to be, so we're still going to have the plus minus. The square root of x squared is just x. The square root of 4 is just 2. I know there's cases whereby this number here doesn't exactly have a perfect square. You just write the root of that number. For instance, if we had a 5 there, we just say root 5, right, and leave it as it is. And the square root of y squared is what? Y. So this is our function, right? This is our function. In other words, now we need to, okay, what happened over here? Okay, seems like everything is all good. Okay, yeah, so this is the function that we need to plot. All right, this is the function that we need to plot. So this is let's plot it. This is the, so normally we start off by doing this, by plotting the main function. All right, we start off by plotting the main function, and then we then plot the inverse. But look, this function is going to be like, you can see that it looks kind of linear, but the problem is that it's got plus minus. In other words, there's going to be two branches. One represents an increasing linear function, the other one is going to represent a decreasing linear function. So we're going to have a situation like this. Right. And then something like that. All right. And obviously if it's negative, then this is actually y is equal to minus x over 2, and that is equal to just x over 2. Do you understand? So this is the inverse. So this is your y, and this is your x. Okay, and there you have it. This is the inverse. So now the question is this inverse a function? I hope you're thinking the vertical line test. Let's do the vertical line, because remember, the two branches actually represent one function. It's not separate, you know, it's not separate separate functions. Okay, and also, can we extend the branches from here going down, also from here going up like that? Can we extend the branches? Can we do that? I'm not too sure about that. All right, I'm not too sure about that, but this is what it's gonna look like, right? Because if you check, the main function looks like this. The main function. And this is just f. All right, this is just f, which is given by 4x squared. Okay. So yeah, it is what it is. So now if we were to draw a vertical line here, you can see that it cuts this function over here, here and there. And what does that tell you? Right, remember the vertical line test, immediately when it cuts the graph twice, then we're not dealing with a function. Right, we're not dealing with a function. But if it cuts the graph once, then you know for sure it's a function. That's the vertical line test. So yes, and yeah, there's something that I've always wanted to tell you, but I just kept on forgetting. So the domain of the main function becomes what? The range of the inverse. Okay, and and vice versa. And vice versa. In other words, the range of the main function becomes the domain. Are you guys with me? The domain of the main function, which is this one, we all know that domain for this function is x element of real numbers, right? X element of real numbers. So but with the inverse, y element of real numbers is going to be the range. In other words, we're just sort of like copying the domain, but we're changing the variable. And if you check, the range is y is greater or equal to 0. And the domain is going to become what? X is greater or equal to 0. Alright? So that means we've plotted the function correctly. X is greater or equal to 0. Alright. So that's the domain right there. Okay. So yeah, unfortunately I cannot say any questions. Any questions, but yeah, this is the thing that I want you guys to really take a note of, that we swap the domain in the range when we're dealing with the inverse. In other words, they can give you the main function, and then they ask you to figure out what the domain of the inverse is going to be, or the range of the inverse is going to be. By using this here, you can be able to predict. So yep. So now let's see what other function we can look at. And this time around, we're not going to have what we call a perfect. We're not going to have a perfect function, just like we had over there. So now let's look at something like this. Okay, let's suppose that we're dealing with f of x is equal to 3x squared. Yeah, but I mean, you guys' functions are easy, honestly. Yeah, because I mean, you're always gonna get something that looks like this. There's always gonna be f of x or g of x or k of x is equal to a, some a, right, and then x to the exponent 2. It's always going to be like that. So let's swap the x and the y. So x is equal to 3y squared. Right? So now let's make y the subject of the formula. So we divide by the 3. Right? So we're going to have this. X over 3 becomes what? So I don't know where I got the squared from. That's why I was just a little bit confused, throughout that time when I was teaching you guys. So meaning that we're going to have the square root of x over 2, because I was seeing something that I was not so familiar with, all of a sudden we're dealing with a linear, function. So meaning that our function is going to be a bit KV like that. Yeah, otherwise it doesn't change much. But yeah, I made a mistake there. So meaning that if there's no squared over there, we're just going to have the square root of x. It's quite unfortunate that when I'm teaching like this, there's no one to correct me, and sometimes these mistakes, they go uncorrected. But it is what it is. I'm not going to stop because there's the downside to this. But anyway, let's carry on. But you see, as when you do it over and over and over again, like, you get to see what misconceptions you might bump into, right? Because now that I was solving this one, I realized that, okay, there's no x squared here. So meaning that when we square root both sides, this one is going to remain with the square root. So we're going to say plus minus the square root of x over 3 is equal to square root of y squared. Okay. Yeah, I'll probably do another example just to just to cater for the flop that I did here. But anyway, let's get on. So there we go. We've got that function over there, so we can further simplify. So this and that, they cancel. This and that, they cancel. So y is just going to be equal to what? plus minus the square root of x over the square root of 3. It's looking nasty now, can you guys see? Not so cool, right? Yeah, but you just gotta know that the form of this function is always going to be like this, right? You mustn't get confused, y'all, please. So it's always gonna be like this, right? Although my drawing skills have diminished, I don't know what happened. It's just gotta be KV like that. Like it needs to resemble a quadratic function like that, a normal quadratic function like that, right? So this is y, this is x, but it needs to be facing you know, positive infinity for x, right? It needs to be facing this side, okay? Right, still the very same function, just that now well, it's not the same function. This one is now a mapping because it's no longer a function. Why? Because if we try the vertical line test, realize that this dotted line cuts this mapping twice. So this is not a function. In fact, we're supposed to talk about restrictions here, and how we can actually make it to become a function. But well, that lesson didn't go so well. But anyway, let's carry on. So this is what we have. This is y is equal to plus minus the square root of x over 3. Right? You can write it this way or that way. It's all up to you. Or you can, alternatively, you could say, okay, f minus, still the same function. And then this is what? This is your f. Okay, looks cool now, right? So that's what we have. And remember, the domain for f, these type of functions, guys, listen, these type of functions, the domain and range, they're always going to be the same. Domain here, domain, it's always going to be x element of real numbers. I know some people, they like using set bold notation. So minus infinity to positive infinity. Please don't use the square brackets, please, please, please. So yeah, that's the domain. And the range, now the range, right? Y is greater or equal to 0, and y is an element of real numbers. And look, these will always be the same, okay? As long as we're dealing with these type of functions, they'll always be the same. But obviously sometimes there's a negative a, and we've got to look into that, right? In other words, your graph is not facing up, it's facing down, right? It's a frown. Okay, so when you're dealing with the inverse, we're simply going to say, okay, the range, we're just going to copy the domain. Domain says what? X element of real numbers. Then we're going to say y element of real numbers. And then domain, we're just going to copy the range of the main function, right? The range of the main function says y is greater or equal to 0. Then we say x is greater or equal to 0. X element of real numbers. Easy, isn't it? This is for f minus, which is the inverse. And that's for f, the main function. You guys got the drill, right? Yes. And it makes sense that x is greater or equal to 0, right? Because x starts from here and goes to positive infinity, right? But you can see this branch here goes forever up. This one goes forever down. That's why the range, which is the set of y values, it's going to be any y value. Any y value is going to work for the inverse. Okay. Now look, we've got a problem here. This inverse is not a function. In other words, the issue that we have is that the vertical line is cutting the graph twice. All right, it's cutting the graph twice. So meaning that we need to sort of like adjust either the domain or the range. In fact, not the domain. You need to adjust the range in such a way that now the vertical line cuts our function once. All right, so we're going to split the range into two sets. Okay, so range becomes, okay, range now becomes, now y starts from so we're going to say y is greater or equal to 0. Y element of real numbers, or y is less or equal to 0, where y is an element of real numbers. So if you go with this one, you know what that means. That means basically you're selecting this branch here, because this branch actually falls under that section where y is greater or equal to 0. This branch starting here, right? But then when y is less or equal to 0, that's this branch here. So if we're only dealing with one branch, then we know for sure the vertical line is going to cut it once. So in other words, okay, we say, let's forget about this one. Let's restrict our mapping only to this branch, right? By saying y must be greater or equal to 0, where y is a number of real numbers. Then when this one is out, you see that, okay, the vertical line actually cuts this branch once. Then this becomes a function. Or we say, no, we don't like this one, we only want to focus on this one. Then we restrict the function to only this branch. We say, our range y must be less or equal to 0, y must be less or equal to 0, and then y is an element of real numbers. Now when y is less or equal to 0, that means we're only focusing on this branch. And if that's the only branch, look at what the vertical line is doing. It's only cutting that branch once, and then voila, becomes a function. You understand? So they always ask, okay, how can we restrict this function in such a way that it becomes, this mapping in such a way that it becomes a function? Because we've all agreed that the inverse of a quadratic function is not a function. Do you understand? Now, how can we restrict the range in such a way that it becomes a function? Because remember, really the problem is with the range. Okay, if the range is inappropriate, then our inverse does not become a function. Okay, so this is the restrictions. You either restrict like this or you restrict like that. So yeah, anything else that I'm leaving out? But yeah, I think so. Remember what I said. The domain of the main function, becomes the range of the inverse, and vice versa. You guys with me, right? Yes, and vice versa. So, okay, we are going to look at a slightly different quadratic function, and this one we're going to actually rush through it because I feel like we've already done too much. I feel like we've already done too much of this. So, but okay, let's say we've got g of x is equal to minus what? Minus 6 x squared. Okay, so find and sketch g of x. This is the inverse on the same set of axes with g of x. Let's do that like a handsome, right? Like a handsome. Let's do that quickly. So first thing we gotta do is we gotta make we gotta swap the two, so x is equal to minus 6y squared. Therefore, now x over minus 6 is equal to what? Y squared. And then what do we have? Plus minus the square root of x over minus 6 is equal to what? Y. Alright, then we plot our function. We plot our function. It's not even a function. It's just a mapping. So yes, right, so let's investigate this one, because we know normally the main function is gonna be like this. That's the main function, right? That's just g. Okay, that's just g. So what's the inverse gonna look like? Is it gonna be still this side, or is it gonna be that side? Haha, that's the big question. All right, that's the big question. But if you look at this function, you can see that x cannot be positive, okay? Because if you put a positive value of x here, this whole thing here becomes negative. And remember the square root of any negative number. The square root of a negative number, you don't want to go down that route. So, meaning that we can plot our function this side. So, this is x, this is y. So, our function is going to be like this. I hope it's going to be smooth this time around. And there we go. Beautiful, isn't it? There we go. So, now we know that, okay, this is y is equal to plus minus the square root of x over minus 6. All right, and this is g inverse, and this is g. Okay, so and obviously for this to be a function, you will have to restrict one of the branches, then you will have a function. But currently, as it stands, it's not a function. But your g, the vertical line cuts it once, it's a function, but here it cuts twice. That's not a function. Are you guys with me? So the g, we either have to restrict our domain, because remember the range as it stands, range is y element of real numbers, domain x is less or equal to 0, where x is an element of real numbers as it stands. But remember what I said, we always need to alter the range in order for us to get the in order for this to become a function, g inverse to become a function. So how do we alter the